Hi everyone, this is a chapter 1, Matter 1.1 Atoms and Molecules. What is the matter? Matter we refer to the anything substance that has mass and occupy volume. It can exist in solid, liquid, and gas state. Clearly we can see that solid and liquid can be weights. But we cannot see gas has weight. Here is the example that air has weight. There are two evenly inflated balloons. If I prick one of the balloon with a needle, the balloon becomes flat. Then you can see the filled balloon shows air has weight. The other example is cooking gas cylinder at home. Matter can be classified into pure substances and mixtures. Under physical process, pure substances can be produced from mixtures. There are two types of the mixture, which is homogeneous mixture and heterogeneous mixture. Example for the homogeneous mixture is hot coffee. It is a mixture of the coffee, water, and sugar. For the heterogeneous mixture, example of the heterogeneous mixture is the mixture of the cereals and milk. So you can see clearly the cereals in the milk. There are two types of the pure substances, elements and compounds. Elements is a pure substance consists only one type of element. And compound is a pure substances consist more than one type of elements. Elements can exist in the form of atoms and molecules. Example of atoms: group 1, group 2, and transitions element, group 18. For the example, potassium, zinc, sodium, that are example of the atoms for the elements. And molecules, example for the molecules, group 17, because group 17 exists as a molecule, such as chlorine, bromine, iodine, and the other example beside that group 17 is oxygen gas and nitrogen gas. Compounds, there are two types. Ionic compounds, for the example, sodium chloride, potassium chloride. Molecules, example, carbon dioxide and H2O. This is the periodic table of elements. As we know, the elements are arranged according to the periods and groups. There are 18 groups and 7 periods. Let's see one of the elements from the periodic table. I take hydrogen. So from this box, you can see that it has atomic number, element symbol, element name, and atomic weights. The value of the 1.008, also known as the atomic mass, is actually the average atomic mass of isotopes of hydrogen. So how to get the average atomic mass? Actually, there are 3 isotopes of hydrogen. It has protium, deuterium, and tritium. You can see that the isotopes of hydrogen has a similarity in terms of the atomic number, but different nuclear number. And these three isotopes of hydrogen can be detected by using the mass spectrometer. And then the result, it can be obtained in the form of mass spectrum. Then you can calculate the average atomic mass after you get the mass spectrum, and which is the total up of the percentage abundance and isotopic mass. Isotopes notations. How to write the isotopes notations? Isotope notation, we refer to the symbol. It must have element symbol together with the nuclear number and atomic number. Example, isotope notation for the hydrogen, isotope notation for the ion, magnesium 2+, and isotope notation for the anion, oxygen 2-. Let's see the isotope notations of hydrogen. From the isotope notations, you can get the number of protons. The atomic number is the number of protons, which is for the hydrogen, it shows that it has one hydrogen. And we know that for the neutral atom, the number of protons same as the number of electron. So the number of electron is 1. Nuclear number is the total of the number of protons and number of neutrons. So to get the number of neutrons, nuclear number minus number of protons, so it is 2. For the magnesium 2+, the number of proton is 12 because the atomic number is 12. But the number of electron, because it is a positive ion, it has less 2 electron. So 12 minus 2, and the number of electron is 10. And the nuclear number, you can get the number of neutrons, which is 22 minus 12. So it is 10. So the last one, O2 minus. The number of proton is 8, but it is negative ion. The charge is 2 minus. So it has more 2 electrons. So the number of electrons is 10. And the number of neutron, 16 minus 8, it is 8. Next, you should be able to interpret the mass spectrum. So this is the example mass spectrum obtained from the mass spectrometer. Y-axis represent for the abundance in percentage, and x-axis represent for the mass to charge. So you can see that from the mass spectrum, okay, the number of peak equal to the types of the isotopes occur. It shows that there are 4 isotopes of ferrum, which is ferrum 54, ferrum 56, and ferrum 58. Then, the y-axis shows that the abundances of each isotopes in percentage. So, you can see that the height of the peak is directly proportional to its abundance. For the example, ferrum 54, the percentage abundance is 5.82%, and ferrum 56, the percentage abundance is 91.66%, ferrum 57, 2.19%, ferrum 58, 0.33%. So if you total up all the isotopes, the percentage abundance is 100%. And the ratio of the mass to charge for each species is found from the value of the accelerating voltage associated with a particular peak. So this one, it refers to the percentage abundance. Okay, next, how to calculate the average atomic mass? There are two types of the mass spectrum. This is the mass spectrum, same as the previous. Okay, because the abundances given is in percentage. And you can use this formula to calculate the average atomic mass, which is total percentage abundance times to its isotopic mass. So this is the isotopic mass for each isotope over the total percentage abundance. So this one is the mass spectrum, but it gives you the abundances or relative intensity not in percentage. It is in the form of the ratio. Okay, for this mass spectrum, you can see that there are 4 isotopes. Okay, and this is the value of the intensity, but not in the percentage. So if the abundance in ratio or not in percentage, you can use this formula. Average atomic mass equal to the total abundance times to its isotopic mass per total abundance. So the average atomic mass, the unit is AMU. Next, after you calculate the average atomic mass, you have to compare with the mass of one atom of carbon-12 atom. Okay, this one is the relative atomic mass. So relative is the comparison. Then the answer, you will get same value as the average atomic mass, but no units. For the example, relative atomic mass of magnesium. So the formula is mass of one atom of magnesium, which is 24 AMU, compared to the 112, okay, of mass one atom carbon-12. So when you cancel AMU, then you will get the relative atomic mass for the magnesium is 24. There is no unit for the relative atomic mass. Let's see the other example. Here, okay, calculate the relative atomic mass of neon from the mass spectrum. So from the mass spectrum, you can see it gives you the abundances in percentage. And it has 3 isotopes. Isotopes neon 20, 21, and 22 with its abundances. Okay, so first, because you need to calculate the relative atomic mass, you need to calculate the average atomic mass. And by using this formula, the percentage abundance times to its isotopic mass that you get from the mass spectrum. So if the atomic mass is not given, you can use this number. Okay, then the average atomic mass is 20.2 AMU. Then you calculate the relative atomic mass of the neon by using this formula. Okay, you substitute the value, then you cancel the AMU 1212, then you will get the same value as the average atomic mass, but without units, because you already cancelled the units. Okay, another example is copper occurs naturally as mixture of the 60.09% of copper 63 and 30.91% of copper 65. So copper, it has two types of the isotope, 63 and 65. Okay, and it gives you the percentage abundance. And at the same time, it gives you the isotopic masses of the copper, which is 62.93 U for the copper 63, 64.93 U for the copper 65. So, to calculate the relative atomic mass, first you need to calculate the average atomic mass by using the percentage abundance given and then the isotopic mass. Okay, because it gives you the isotopic mass, so use this isotopic mass. If the question doesn't give you the isotopic mass, you can take the isotopic mass from the isotope notations. Okay, from the symbol here. Okay, you have to understand that mass for one atom, or it also known as the atomic mass, and mass for the one molecule, or it also known as the molecular mass, the unit must be in AMU. For the example, okay, given the relative atomic mass of nitrogen is 14, then this one is the relative. That's why the value doesn't have units. So the mass for one atom is 14.0 AMU. Example for the molecule, we have here relative molecular mass of CH4. The value is 16.0. This is a relative molecular mass, that's why it doesn't have units. So mass for one molecule or molecular mass, if the question use terms molecular mass, means that the mass for CH4 molecule is 16.0 AMU. So that's all. Thank you.